Hello, I'm Nam, and this is the second video in the ROS tutorial series. Today we will be controlling a robot to go around this really difficult obstacle course, which I designed in GIMP with a paintbrush. No one has ever defeated this track, so we will find out whether you can do it. In order to do this challenge, we're going to learn some Python and OpenCV. Don't worry if you don't have experience with them. I will show you step by step how to code in Python and how to use OpenCV. This video is meant for anyone new to ROS. I remember when I first got started with ROS, which was maybe 3 years ago, I don't have these kinds of resources available to me. There was so much to learn, but nothing really interesting to help me learn. I remember trying to go through the official ROS tutorials. Let's just say that I quickly got bored of implementing publishers and subscribers. Like, okay, I know how to implement them, but what's the point? So I want this video to help to motivate that point. My goal here is to show you what's possible in ROS and help you understand the big picture. And hopefully that will shine some light onto why ROS is the way it is. If you're absolutely new to ROS, I would recommend you check out my last video where I go a little bit slower over ROS and go through the code line by line. But it's not a requirement. So if you want to start with this video, then you're welcome to do so. Let's get into it. I'm inside the project repository that we will be using for this video. So you can see that we have all the files here in the middle. The files are very similar to the files that we used in the last video. In fact, these files actually build on top of those. I made changes on top of those files. But I'm not going to be going into the details here in this video because I already done that in the previous one. So if you want to try to understand what all these files do, then do check out the other video. But for the sake of today's project, we want to kind of quickly go over this and then just get started with computer vision. So there's a README file that contains all the instructions on how to clone and run the project. So let's follow it. So I'm going to put this to the side and I'm going to open up a new terminal. And I will open up the File Explorer so we can see what's going on. So this calc.ws folder was from previous tutorial, so I'm just going to delete it for the sake of this one. Okay, so yeah, got this. So I'm already in my home directory, so I'm not going to run this. Let's create the folder. Okay, let's go inside the folder. We're inside here, and we're going to clone our repository. Okay, so we have all the files in our catkin source folder. Now we're gonna go ahead and update our dependencies. So for this tutorial, we're using OpenCV. So this will install the OpenCV packages for you. So let's go back. We're gonna do ROS update. And I'm going to run this. Make sure that this matches your ROS distribution. I'm using ROS Noetic, so this is correct for my case. Okay, so everything's already installed. Okay, we can move on to the next step, which is building our tutorial package. So we're gonna go back into Catkin, which I'm already there. So we're gonna build our project. Catkin build computer vision. So remember that this is specifying the package that we want to build. We could have multiple packages inside our Catkin source folder. So here we're specifying that we want to build this package here, computer vision package. We want to build this package. So yeah, let's do it. Okay, and finally we want to source our environment. So this will tell your computer where all your project files are in order for you to be able to run commands like ROS commands. So source. And finally, we can launch our robot. Okay. Welcome to Ultra Robo Soccer Racetrack. This is an upgrade from last year. Last year, when we run the tutorials, we had a simple kind of circular racetrack, which seemed kind of easy. So for this year, I thought to myself that maybe I'll try to make something more interesting for you. And so this is what I came up with in like an hour on GIMP with a paintbrush. So you got this kind of broad curve just to test your initial line following skills. And then here we have this a bunch of sharp turns here, which will really test whether your robot can turn these kind of tight corners. More interesting sharp turns here, more rounded. And then finally we have a curve or a cross that you have to go through. So yeah, I haven't actually done this course before. I mean, I haven't actually made the robot go around this course, so I don't know how hard it is. But I guess you will find out yourself whether it's hard. But yeah. So I prepared a small program for this project, and if we go back to source, I prepared this motor controller.cpp program. If you remember from our previous video, I talked about how the idea of ROS is that we want to create small programs that do like very specific tasks, and we break up the entire project into these small programs that talk to each other via these like network links, topics. So I showed you a diagram of an example robot that you might be implementing, and actually this example is not too far from it. If you remember, we had a motor controller in that diagram, which was written in C++, and its sole purpose was to take in commands and then just control the motors, make sure that the motors run at the right speeds and stuff. So in that same idea, I wrote this motor controller here. Let's go inside, which does that. We tell it what we want the robot to do, and the robot will execute on it. So in my case, I have this giant if-else statements where it looks at the command that it received, and depending on the command, it will set the speeds of the motors. So you can see here I have go, back, left, right, and then the else condition is just stop the robot. It's all zeros. So that's what the motor controller does. And how I implemented it is I used subscribers and publishers. So if you go down here to our main function, you can see that I defined this subscriber, which listens on this motor commands topic. And if it receives a message on that topic, what it does is it will call this function, commands callback, which I have defined up here, commands callback. So whenever you send a message to it, it will go through this entire function. So just to quickly go over it, what it does is we receive this message from the topic, we read the message from it. In this case, we're reading a string command. We take that string and we compare it to the different options that we have, that I have specified. So if the string says go, we set the speeds to this, and then here we send the message, so we publish it. And the publishers are what we have done in the previous video, so that should be familiar to you. The only new thing here is the subscriber, which uses these callback functions. So that's kind of new. So let's see this in action. So we have built this. Project just a while ago, so we should be able to run it now. So I'm gonna open up a new terminal. Make sure it's slightly bigger. Okay, so we're gonna launch this, or not launch, we're gonna run this node. So when you ran that catkin build command, what happened is catkin went into our cmakelist.txt and it looks at what we want to build. So skipping over all these stuff, if you look at this line over here, we told our build system to build this motor controller.cpp file, and we told it to compile it into this motor controller file, and then we link libraries to that file. But the important thing is that it's called motor controller. So in order to call it from our command line, we're going to do ROS run. Before we do that, actually, or let's just try it. Let's see what happens. I'm going to do ROS run. So the package name, in our case, it's computer vision package, and then the name of the executable. In our case, it is, what's it called again? What did I forget? Motor controller. Motor controller, and it works. Okay, I didn't expect that to work, but anyways, if you press Ctrl+C, it'll quit the program. The reason I didn't expect it to work is because I don't think I sourced my my setup file. Anyways, just make sure that before you after you build your project, you also source your setup file. So in this case, we want to source devel setup.bash. And if we look inside the folder, going back to catkin, you want to source this devel setup.bash. This is just a thing that tells your system where your ROS packages, ROS files are located, in order for it to be able to find them and run them. Okay, but it seems like I've already done this before, so I don't know. Anyways, I'll source it anyways. So that's done. And then let's rerun that command that I just ran. So you can go back through history on the command line, and in order to do so, you just press the up and down arrows. So in this case, I'm pressing up arrow, and this brings me through the history of all the commands that I typed. So I want to rerun this command here. So I'm going to enter. And what happens is it's running. Okay, I'm going to open a new terminal. So I'm just going to press here on this tab. And the way this works is, going back to this code. The way this works is because we're implementing a publisher. Remember that last time in the last video, we were typing commands into our terminal. But this time we're not doing that. We're implementing a subscriber publisher. In this case, this node is subscribed to motor commands, and it accepts a string message. std messages string. So in order to talk to this node that we just created, we have to publish to this topic. So if you remember from last video, there's a command called ROS topic pub, which lets us publish to the topics. In our case, we want to publish to, let's see, what was this called again? Motor commands. So I'm just going to copy this, because this is what it's subscribed to. I'm just going to paste it right here. Now, I'm going to press tab just to auto-complete the variable type, because I don't want to type. And it should just fill up your thing here. Okay, so I'm going to press tab again. And yeah, there we go. So ROS topic pub, motor commands, string, and then the data. So inside the data, we're going to type in one of the commands. So go. And that should make the robot go. You can see it, and robot's moving. So press Ctrl-C to terminate. So I'm going to press Ctrl-C. So the program stopped. The publishing program stopped. But as you can see, the robot is still moving because it's the way Gazebo works. It just kind of latches onto the last command and it kind of remembers it. Now let me type right, so that we turn right, and the robot goes to the right. Okay. Wait, let's see if I can make this entire course just by typing the messages. Let's go left. Okay. Left. Oh, this is so bad. Let's go straight. Go straight now. Go left. Okay, let's wait. Let's wait. And left. All right, anyways. So this is a way for you to control the robot through this motor controller. This is not how you would implement this in practice. Like I wouldn't imagine self-driving cars having these kind of commands, go back, left, right. But it's like a nice way to kind of understand how a motor controller works. It's kind of easy. You're typing commands, go, back, left, right. So it's pretty intuitive. So good way to kind of start learning about this. What was I going to say? Yeah, I think that's all I want to show you here. Is just this obstacle course and this motor controller, which you can use to control this robot. I guess I'll show you how to modify this code in case you want to modify it. So for example, say if I wanted to add a new command, I could say, let's see, what can we do? For example, I could add another else if statement. Sorry, my caps lock is on. Else if command is equal to go really fast. Okay. And I actually don't know what the maximum, what the limit is on the motors, but I guess we'll find out. Let's say you want to go at 10, I think radians per second is the unit. I think it's radians per second. Okay, so we have this new command called go really fast. We set it all to tens, and let's see how that goes. So the nice thing about ROS is that you don't have to restart. You don't have to kill the entire program to test your changes. In this case, because we only modified the motor controller, we only need to kill the motor controller itself. So this is the publisher. Just clear the screen. The motor controller is here. Remember the motor controller. So I'm just gonna press Ctrl C, and that kills the motor controller. So I'm gonna clear the screen. So since we modified our C++ file, and C++ is a compiled language, we have to build it again. So we're gonna do catkin build computer vision package. Okay, so we're gonna build it again. Okay, so you don't have to source it now because your system should remember. It should remember where the files are. Okay, sorry. Okay, so I'm gonna clear the screen. I'm gonna rerun the motor controller node. So I'm gonna press up arrows to go back to history. And here's the motor controller, press enter, and the motor controller is running. So we're gonna go back to this window, our third window, and we're gonna publish to it. So I'm gonna press the up arrow, we get back to this command. Now instead of left, let's use our newly written command, go really fast. Go really fast. All right, let's see. Oh. I mean, that's not what I expected, but that also works. Well. Okay, let's stop it. So if you type any other message, it'll stop the robot. So just type whatever, it should stop. Stop. Oh no. Oh no. Oh no. I don't think I stopped in time. Oh, no. Oh. Well.
Oh
okay.
my god.
Let's reset. So I'm gonna press Control R. Actually, I don't remember. Go into, what was it? File, Edit, Reset Poses. I think it was Reset Poses. It'll bring our robot back. All right. So there you go. So that's one way to like modify it. Another example is, another example is if you want to say turn left, but not as much as it's turning here, you could play around with the values here. You could make it 0.6, 0.7, whatever you need. So you can add any kind of command you want. You could also add commands to turn the camera around if you need to. But in that case, you would have to add another publisher in order to control that camera. But yeah, so that's how you add commands. Another thing I want to show you is RQT graph, because since ROS is all about nodes and the graphs, it's good to be able to visualize what's going on in the system. So one tool that ROS provides is called RQT graph. If I enter this, it should open up a new window. So as you can see, this shows us the nodes and the topics that connect the nodes. In this case, we have a motor controller that's talking to Gazebo. Here, so let me put this to the side. Okay, let me open up a new window. Okay, so we have a lot of tabs now open. But when you publish, so if I do ROS topic pub motor, okay, I'm gonna press tab just to autocomplete it for me. I'll just publish whatever, it doesn't really matter. Stop. Okay, anyways, when you publish this, what happens is it will show up in this RQT graph. So I think if I press refresh here, oh, there you go. So let me zoom in. So what happened? So you can see that when we publish our topic from command line, it creates this new node. In this case, this node is publishing this whatever random string of letters that I sent, and it goes into this motor controller. The motor controller then sends these commands right back into Gazebo in order to make the robot move. So RQT graph is helpful for us to visualize what happens in our system. So let's see what happens if I kill this motor controller from command line. Okay, so let's go back to terminal. If I were to go to here, this tab where we're running our motor controller, and if I press Control C, which kills the program, and go back to our RQT graph, refresh it. What happens is the motor controller disappears, and there's no more connections between our ROS topic to Gazebo. See, there's no more connections anymore. Okay, before we move on to the next section, I just wanted to step back and have a look at the big picture so that you know what we're trying to accomplish here. So we have our gazebo simulator node running. So what happens is we will pass in our URDF file, which tells gazebo that our robot has 2 wheels, has a body, and a camera. So gazebo knows how to simulate our robot in the world. So on top of that, we will write 2 nodes. We will have the motor controller, which I just showed you, and we will be writing a planner, which will make decisions based on what the robot sees in the world. So all these 3 nodes will be connected in such a way. Gazebo simulator will talk to the planner on this camera image raw topic. So it's going to be sending pictures to the planner, and the planner will process the images, do its thinking, and then it'll send its and it'll talk to the motor controller through the command topic. The motor controller then will send its values through these 2 topics, the left wheel controller command and the right wheel controller command. So this is what our high-level diagram looks like. To make it a little bit more concrete, I'll give you an example. So say the gazebo does a simulation step and it figures out that the robot is in some position in the world and it sees some image. It'll send that image to the planner. The planner will look at this image and be like, there is a left turn coming up based on the pixel values in this position. There's a lot of yellow pixels on the left side, so there's probably a left turn coming up. So it decides that the robot should take a left turn. So it'll send a left command to the motor controller. The motor controller will take that command and it'll, based on that big if-else table, it'll figure out that for a left command, we should send these certain values to gazebo. And that makes the robot turn in simulation. And so you can see how this process repeats itself because the robot will move to a new position. It'll send a new picture to the planner. The planner will evaluate the picture again and be like, it'll adjust its course. It'll send maybe another left command. Maybe it'll send a go command. But it just keeps repeating in a loop, going in a circle. From gazebo to the planner to the motor controller, back to gazebo. For this section, we're going to write our planner node. Now, I haven't really planned this out, no pun intended. So what I'm gonna do is I'm just gonna go from scratch, just try to figure this out. Haven't really thought about how I'm gonna do this. Haven't really worked with OpenCV in a long time. So we'll see what happens. But I think this will be a good way to show you how a software engineer might go about solving a problem. Yeah, so let's do it. Okay, so first what we're gonna do is let's run our simulation. This to the side. Okay, let me open up the terminal. Control-Alt-T. Okay, okay, so I'm going to go into Captain, see Captain WS. Let's source our setup file. Okay, so here I'll show you. So normally, since I've already built the project, I would just run ROS launch computer Okay, normally I'll just run this command to launch our simulation. But as you can see, we get an error. And that's because we didn't source our setup file. So if we source our setup file, and then we try to run this command again, it works now because it was able to find the files. Anyways, okay, so we're in our simulation. Okay, so we have simulation. Okay, so step number 1 is for us to write our node. So I've already prepared the Python file. So if you navigate to cat.ws source tutorials 20, go to source. I prepared this Python node. So if you go inside, so this is currently what it does. Just prints a message to the screen. So if you've never worked with Python, Python is a very popular language currently. And one of the main features of it is that it's a interpreted language, meaning that you don't have to build Python files as you would build a C++ file. So for example, let's run this first. So if you go here, let's open up a new terminal. Okay, let me navigate into the folder first. So okay, so inside the folder, you can see the planner.py. So to run this program, we're gonna do Python 3. Okay, so Python 3, and then planner.py. So that runs our program. Now, if we want to modify it, we say, for example, do I don't know, something like this, save it. So normally with C++, you would have to go through the whole build process, rebuild your project, and then you run the thing, right? But with Python, you can just run it again, and it updates your, it already uses the updated file. So this is one of the advantages of Python, that you can just make a change and then just test it really quickly. Something you can't really do with C++. Now, the only downside of Python is that because it's interpreted language, it's very slow. So you won't get the speeds, you won't get like same speeds as like C++ language. So yeah, so just keep that in mind when you're picking between C++ and Python. That's just like a big overview, but of course there's like a lot more details if you like look into the specs of both languages. All right, so let's see, what do we have to do here? So the first thing is we want to be able to read in the images, right? So we have camera on the robot and it's publishing images. So let's have a look at the topics first. So I'm going to do ROS topic list. So you can see all the available topics in this instance of ROS. The one we're interested in is camera. So we have the camera related stuff. So we want to take in the camera raw. Okay. All right, so we know the topic. Now, obviously, I don't remember how to do all these steps for subscribing and showing the image. So, I'm going to turn to Google to help me out. So let's see. We're going to do ROS subscribe image. Let's see what that gives us. Image subscriber. Oh wait, no, I don't want C++. I want Python. Okay, let's see this first one. Converting between images. Okay, so ROS has different image format than OpenCV. Okay. Oh yeah, should probably mention that we're gonna be using OpenCV to do the processing on the images. OpenCV. Let's go into the website. Yeah, so you can see OpenCV is pretty big. Open source, optimized, cross-platform. But what is it? The CV stands for computer vision. So basically it's a library which gives you a bunch of different tools in order to manipulate images, extract stuff from the images, draw on the images, and so forth. So it's a really, really useful tool if you're working with images, specifically computer vision related stuff. Anyways, but yeah, we're going to be using OpenCV for this. But before we can use it, we have to first get the images from our gazebo, from our robot. So let's see if this has any information about how to do this. This is about converting images, which will be useful. Okay, so here's an example ROS node. Okay, let's slowly copy all this code into my file. Let's see. So a bunch of stuff. Okay, so first thing is, let me make this bigger so you can see what's going on. How do I make this bigger? This view. No. Oh, how do I make this bigger? This. No, that's not what I want. How do I exit? All right, so finally figured out how to make the font bigger. So hopefully this is more legible for you. Anyways, close that. Okay, so let's copy this code. So we're gonna do, so this looks like something we need. Import ROS.py. This looks like something we need. Import CV2. Okay. They're using classes. We don't really need to use classes here, so because we want to keep it simple. Let's see. So we got image publisher. Okay. Let's put it right here. Image. Actually, no, we don't want publisher. We want subscriber. Here, we want this subscriber. Sorry. So let's get rid of this. Put in this. Oh, shoot. It's too big. Yeah, so image subscriber, let's just call it, let's make it shorter. Image sub ROS by subscriber, our topic. Okay, we'll add it later. We want a callback. So if subscribers, what happens is you need a callback function. So we're going to define a function called image callback. And for now, we'll just split this. But basically what happens is whenever our subscriber receives an image from Gazebo, this subscriber will call this function here. So, okay, first of all, we don't need this. We don't need that. Okay, topic. We will update that soon. So you got subscriber, we got the callback. Inside the callback, oh, make sure that the names match. So I've got image callback here, callback. So we need to accept some kind of data. Okay, and then we'll just copy this. Okay, so instead of pass, I'm gonna have this. Oh man, this is so ugly. Okay, one thing with Python is you have to make sure that the indents are exact. So you can't have like 3 spaces here and then I don't know 4 spaces here and have 2 spaces here and then have 5 spaces. With Python, the interpreter really cares about the indents, so you have to be very consistent. So if you use 2 indents, if you use 2 spaces for an indent, you have to stick to that. So I'm gonna use 2, just for ease of this tutorial. But it's really up to you. You could go with as many spaces for indents as you want, but you have to be consistent. Okay, let's see. So, okay, there's gonna be a lot of modifying here. Okay. So we also want to import this CV bridge function. Okay, so we got ROS by CV2, CV bridge. Let's see, what else do we need from here? ROS pin. Yeah, I guess we're gonna put ROS pin in here so that it doesn't quit right away. Okay, what else do we need? The image type, string, CV, sys. Okay, I think that's all we need. So let me go back to our ROS topic list, and I'm gonna copy this image topic, image raw. Okay. So in the place of the topic, we're gonna put image raw. Okay, so I think this should work. Not too sure. Let's try running it. So I'll clear my screen. And we're gonna run Python 3 planner.py. So let's run it. Okay, so there is an issue. Name image is not defined. Okay, so image. So I think I forgot to import this. Okay, so I'm gonna import this image. Oh, no. So this image is being used here because we need to specify the type of message that we're receiving. In this case, we're subscribing to this topic called camera image raw, and the message type is an image. So just to show you, in ROS we have different message types. So image, message. If we go into here, you can see this is kind of raw. It's just a raw text file, kind of, almost. But basically this shows you the sort of the image, like base image type in ROS called sensor messages image. And you can see that we're importing it here. We have sensor messages image, right? So this is what it's referring to. And if we look inside, this is what's inside this message. We have a header, we have the height and width of the image, we have some encoding. Oh yeah, the encoding type of the image. And then we have a bunch of other stuff, and then the data itself. The data is the actual image values, the RGB or BGA or whatever. This is the image itself. And that's what we're interested in getting from Gazebo. Anyways, I'm gonna close this now. Okay, let's go back to terminal and try to run it again. So run it. There's still a problem. Image is not. Oh, I forgot to save it. Okay, so hit Control S to save. You should see that there's no more star here. So clear, and let's run it again. Okay, let's see. What is the problem now? ROS by, that's been. Must call init node. Oh, that's true. So we forgot to initialize our node. Yeah, let's see. What is this image converter? Image converter. Oh, that's a class. I see. Okay, so we need to copy this. So before we can use ROS, we have to initialize ROS. Okay, so we have to give it a name. Let's call it my planner. Okay. Actually, now let's call it my planner, just so that we can kind of make it distinct. Okay, so let's run it again. Python planner 3. And okay, now we're okay. There's a different error now. What is this error? Our bridge is not defined. Okay, let's kill this. Control C. Bridge is not defined. Okay, so what is this bridge? Right. CV bridge. Okay, let's copy this line and put it in here. CV bridge. Yeah, okay. So what this CV bridge does is it helps us convert from one format of an image to a different format of an image. You can think of the image format as like a kind of different language, say like English, French. So for example, Gazebo speaks in French, but OpenCV doesn't really understand French, so we need to convert it to English, something that OpenCV can understand. So that's why we have this bridge. It is to convert the different image types between the whatever Gazebo ROS into OpenCV, so that OpenCV can use those images. Let's see. Okay. So we've got the bridge. Bridge is used here. Yes, we have this try except thing. Don't really want to get into try except too much. But basically what it does is we're gonna try to run this. And if there's an error, we'll just print it out and say that, oh, there's an error. And then we just keep going. We don't exit. So this is needed if you don't want to if you don't want to stop your program if there's an error, if you want to keep going. Okay, you know what? I'm gonna try to take it out just to keep the code simple, because I'm not sure whether it's actually needed. So let's give this a try. Okay, all right. Let's try to run this again. And hey, it seems to be working. Okay, but what is it actually doing? It's not doing anything right now. We're just converting this data into something that I guess OpenCV can work with. So how do we actually display the image? So in order to do that, I already saw that this code here has something to display images. Let's see. CV2 imshow. Image window. Wait. Okay, so I'm gonna copy this right here. Let's call it, yeah, image windows, probably fine. Let's call it raw image. Okay. And we're gonna pass in this CV image, and then we're gonna do CV2 wait key. And I believe this is to wait for a certain time, but I don't remember exactly, so we'll see. Okay, let's try running this. Hey, you see the image. Yeah, there you go. So this is the OpenCV window, and you can see what the robot sees. So that's cool. That wasn't as hard as I thought. Okay, so let's try moving the robot and see if the image updates. So let's say we rotate the robot a tiny bit. Let's see what it sees now. Oh, hey, there you go. Nice. So now we're able to see what the robot sees. Here, let's try moving the robot. Running the terminal. Let's make this bigger. Let's do ROS topic pub. and I'm gonna publish into motor. Is it motor commands? I forgot. Okay, let's see. If you press tab 2 times, it should give you the options. So we wanna publish into camera controller command. I'm gonna publish into. Oh, where is it? Oh, we forgot to run the motor controller. That's why. Okay, that's fine. We'll just publish to one of the wheels. Okay, where is the wheel? Left wheel command. Okay, we'll just publish to that. So we're gonna publish to left wheel command, and let's pass in some value. Let's see. Let's put in 1. So that should, yeah, there you go. So the robot's moving, rotating now. And we can see that it is seeing the world. Cool. Okay, so now how do we make the robot do stuff based on this image? Let's see. So we have the image, we print it out. Let's do something with this image now. So let's I think we should talk about the strategy. What should our strategy be for making the robot move about the base? Move about the obstacle course. So I'm trying to think of something simple. Let's see. Where's my GIMP? Where is my GIMP? Okay, so we have an image. So how do we actually do stuff with it? So I think first we have to talk about what an image is. So you probably know that images consist of pixels. Basically, images is like a X by Y grid of pixels. If we were to zoom in, how do I zoom in on this? If I were to zoom in onto this image, you'll notice that you can see these little squares, right? You can see the squares on the image. So these are the pixels that compose the image, and each pixel has a value. Usually for an image, we have 3 values, red, green, blue, RGB. So each square here has 3 numbers associated with it. So zoom out. So what I'm thinking what we can do is we can look at a certain line. So for example, how do I draw lines? How do I draw anything? Brush. Okay, brush is fine, but how do I make it smaller? Size. Oh, no, that's not what I want. Okay, that's good. So I'm thinking, why don't we look at uh, the line in front of us, like here, horizontally, right? And we pick, let's say, midpoint. We pick another point here. We look at 3 points. And depending on if we see yellow or if we see gray, we will tell the robot to turn left or right. So for example, if this pixel, if this like point here sees that there's a lot of gray in this area, then we will turn right. If this point sees that there's gray on this side, then we'll turn left. And then this, I guess we don't really need this middle point then. We don't really need it. So we just need 2 points on this side. And then depending on what we see is the action we take. Is that gonna work? We get to that point.
3 hours later. One eternity later.
Not sure it's gonna work. Probably not. But let's give that a try. Yeah. Another thing to note about images is that there's a coordinate system within the image, and usually it is something like this, where this is x and this is y. So the top corner over here is usually a point at 0, 0. And here you just go into 0, and then this is the width x. And then down here is the height, or I guess just go y and then 0. This point down here. This point up here. So that's a coordinate system of the image. So if you are to like count the pixels and all that, and we were to like zoom in on this place here, this little square is 0, 0. The square next to it, you can actually see the numbers here. We have 0, 1, 2, 3, 4, and so on. So you just kind of count like this: 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, da 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 da, 1, 0, 1, 1, 1, 2, so on. So that's a coordinate system for the images. Okay, let's give this a try. Okay, so I'm just gonna close this. Don't need to save it. Okay, so first let's draw some lines in our image so we can see what's going on. So raw image. Yeah, why don't we just use this existing window to display our image. So how do we draw a line on our image? That's a good question. I don't know. Let's find out. CV to Python, draw a line. We have a bunch of results here. I'm gonna trust the first source. Okay, Syntax. CV2 line. Okay, so we're gonna do, let's try this. CV2 line. We're gonna pass in our image. Need a start point. Let's draw a line from let's see. I don't know. Let's say 100. 50. Oh, before we draw the line, I'm gonna comment this out. This is the comment for Python. So this will ignore this line when we run the program. So before we run this, let's print out the dimensions of the image. So I want to print out print cv image dot is it shape? I think. Okay, let's see if this works actually. I'm not too sure. Okay, run this. Oh, it works. Okay, so the image shape is 800 by 800 by 3. So it's a square, 800 by 800, and then there's 3 numbers. And you can actually see those numbers at the bottom of the window here. You see the RGB? If you move your mouse around, you can see that the RGB values change. So if I move to the white, sort of the light gray area, the RGB values are high. If I go to the dark area, the RGB values are low. So there's 3 values in each pixel. Just remember that. Okay, so I'm gonna kill this program. Okay. Let's try to work with black and white images first, because I think that'll be a lot simpler to work with. So I want to convert it to black and white. To black and white. Stack Overflow. Usually a credible source. Okay. Step. No. Read a grayscale image. Okay, how do I convert to a grayscale though? Okay, let's have a look at the first one. BGR to gray. Okay. Threshold. I see. Okay, why don't we try doing this? Copy that. Paste it right in. CV2, CV color. Original image is CV image. We want to convert it to this color space, or from BGR, which we have here, BGR, blue, green, red, 8 bits, I think. And I'm going to convert it to gray image. just stick to our convention, gray image. And let's display our gray image here. Okay, let's see what happens. Okay, we're gonna run this. And yeah, nice. So now we got gray images. Cool, 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 cool. So another thing that this this website is saying that we can also do a threshold. The threshold on this image. Binary. Gray image. What is this? 127 to 55. So what are these two images? Okay, let's run it. But basically, this will convert our image from grayscale. Right now you can see at the bottom left here, it's very small, so it might be hard to see it. But basically, instead of 3 numbers, now we only get 1 number. So that kind of makes it easier for us to work with. So it's only 1 number now, from 0 to 255, where 0 is black and 255 is like white. Yeah, I wonder if we should try to use this. We should try using this thresholding thing. Okay, maybe let's skip on this. We'll see what we can do with our grayscale. So close this, close that. Okay. So we converted our image into gray image. Now let's try to draw a line on it. So CV2 line, CV image. We're gonna pass in the coordinates. So, okay, let's get rid of this actually. So we know that the image is 800 by 800. Okay, width 800, height is 800. So let's draw some lines. I want to draw something at the bottom of the image. So let's say 700. So the first value is y, so 700. Meaning we go down 700, and then we go to the left by I don't know, 300. So that's our first point. Our second point will be also 700. So we want the line to be horizontal, but our end point will be 500. Okay. Oh, did I just close the? So endpoint, then we need to pass in the color. In our case, let's just draw a black line. So we're going to pass in 0. And thickness, let's do 5. I don't know how that's going to look. Okay, now we're going to rerun this. And nothing happened. Okay, let's go back. So CV image, is it supposed to return something? thickness, endpoint, color. For PGR, pass in tuple. Thickness is thickness in pixels. Return image. Okay, right. So it returns an image. So let's return our gray image. Okay, so whatever it returns, put it back inside this variable, gray image. Okay, so let's go back, rerun. And, oh, hold on a second. This is vertical line. But also, it's back to RGB, so that's not what I wanted. Hold on a second. Okay. Right. Instead of CD image, I should be drawing on the gray image. So that's one. Number two, I guess this is X then. This is XY. So let's flip the numbers around. 300, 700, 500, 300, nope, 300, yeah, okay. And if we rerun this, no, that's not what I want. Come on. Oh, yeah, what? 700. Okay, there you go. Now we have the line. So if we move our cursor around here, you can actually see the XY things at the bottom corner. So we got 300, 700. We have 500, 700 here. Yeah, so I guess this is another way for you to like figure out where the pixels are. Just kind of move your mouse around the this OpenCV window. Okay, so that's our first step. We want to visualize where we are looking. So these are the points. So what was our plan again? We want to just check the values on this side, check the value on that side, and then based on that, we either go straight, left, or right. Okay, let's do that. Okay, so how do you actually read the values here? So how you do it is you take a gray image and you can access it as like an array. So because it's a 2D array, it's a 2D grid image, we can access two values. So for example, if you want to read a point at this corner, let's call it, what is this, 300, 700. So it's going to be 300, it's going to be 700. Okay, that's our first point. Let's print it out so that we can see what it says. And likewise, we're going to print out the other point at 500. So actually, let's let's do this. Let's print it out on the same line, so it's easier to read. Okay, so I saved it. Let's rerun it. And you can see that values are being printed out. Now, why is it 0? It is 0 because we are reading from this image. Okay. Okay, no, that's not what I want. So because we colored this black, when we access the value on this image, it just comes out as 0. So that's not what we want, right? Okay, so before we draw the line, let's print out the image. Let's print out the values first, and then we draw the line on top of it. I think that'll fix our issue. Okay, So let's rerun this. Okay, that looks better. So you can see the values that are being printed out. So you have 80 over here, and we have 80 over here. Let's try to move our robot into a different position and demonstrate to you how it works. So, oh gosh, where is our robot? Oh, there it is. Okay, so let's rotate it. Okay, okay, do you see this? The left point here is seeing the gray part, right? The right point here is seeing the yellow part. And so that's why you can see the different numbers here. We have 80 on the left, and we have 110 on the right. So in this way, we can kind of see the where the line is. Okay, so let's use this to try to make our robot do the obstacle course. All right, so let's take what we have here and develop logic around it. So let's see. What can we do? Okay, let's create a new function. Let's call it I don't know, plan. And it's gonna take in it's not taking two values. We're gonna take left, right, and we're gonna do something to it. We're gonna return a command. Okay. But also just publish the command. Yeah, that's true. We can publish command. Okay, so for now, it's not doing anything here. Let's left, right. So what's going to happen is we're going to call this function plan, and we're going to pass in the two points, the gray image point and the left one and the right one. Okay, so plan, pass in the left point, pass in the right point. Okay, so first thing we're going to do is we're just going to print out the values. So we're going to print out left, we're going to print out right. And that's all we want to do for now. So let's run this and see what we get. So Python planner.py. And okay, so yeah, so here we go. We're printing the values. So it's the same as before, but now we're putting it into a function, just so we can separate the logic out. Okay, so now what do we do with these values? What can we do? Left and right. Okay, let's do something simple. If left is smaller than, and we can, let's define a threshold value. And let's call it, let's say, I don't know, what's in the middle of 255? 255 divided by 2 is like 120. So let's say threshold new value. So if left okay, this could be complicating things. Trying to think of a better way of doing this. No, okay, let's do this. Let's do this. Is okay, let's create a new function, call it is white. Okay, it'll take in one value and it's going to return value is greater than 120. Okay, so what we can do is we can be like if okay, you know what? Let's stick to the convention. So if left is white and is white, and if right is white, if right is not white, not is white right. Okay, this this is like definitely not proper English, but I guess you get the idea though. If right is not white, if left is white, we're gonna let's print. Okay, so if if white, if left is white, then let's go left. Okay. If left is not white and right is white, then let's go right. If, I guess I'll do it here. If both of them are white, then we just go straight, right? So we're gonna go. That was our command from the motor controller, if you remember. Go to motor controller. Oh, I did not need to do that. We open it with our, forget it. So we had, go really fast, back, left, right. Okay, so those are our commands that we have available to us. And so that's why I'm printing these values out. Okay. So right now, this won't do anything. This is just printing the values to the console. So this is just for us to see what happens. So I'm just gonna stop it here. I mean, just save it here, and let's try it out. Oh, okay, that did not work. Let's see why. So printing this, if this is white, value left, passing left. This is white and this is not white. Okay, so I expected this one to go off. Is white. Left is not white. And right is white. Now let's call it yellow, because I think this is more accurate to what we're seeing in the world. Is it yellow? Okay, so is it yellow? Left is yellow. Left is yellow. Return value greater than 120. So if the value is greater than 120, we return true. Okay. What are we seeing here? What are we seeing in the command line? 120. Oh, so both of them are false. Okay, I see, that's why. So let's lower our threshold to 100. So if it's above 100, then we think that it's yellow. If it's below 100, we think it's gray. So let's give that a try. Okay, there we go. So right now it's thinking, oh, I see yellow here and I see gray here. So let's turn right. Now, if I move this here, if I move it, so it's turning right, and if I turn more, it's still turning right. More. Now it's like, okay, I see both are yellow, let's go straight. So that's working. Now if I go to the left, okay, so now it's seeing gray on this side, and it's seeing yellow on this side. So it's like, okay, it's time to turn left. Okay, so that kind of works.
Cameras is a plural form of camera. Camera is usually defined as equipment for taking photographs, usually consisting of a light-proof box with a lens at one end and light-sensitive film at the other.
Thanks, Alexa. Okay. Let's see. All right, yeah. So this works. So let's try to actually make the robot go. Okay, okay. And I'm kind of excited for this. I'm not gonna lie. All right, let's clear the screen. Okay, so now instead of printing these strings, let's actually publish them to our motor controller. So first, let's define the command. So I'm gonna have command is equal. So by default, we're just gonna have it stop. Okay, so we'll just say stop, and then depending on what it sees, we will update our command to be that. So let's update this command to be go. Actually, you know what? Yeah, let me keep the print statements. I think they're going to be useful. So command is equal to. Actually, you know what? Let's get rid of this. Command equals to go. Command is equal to left. Command is equal to right. And then we'll print out the command so we can see what's going on. And then here we're gonna publish our command. So this is just a comment, just to remind us that we have to do this. Okay, so we print left, right, we print command. we can just print all of this in the same place. So left, right, and we print what command we get. And then, okay, we need to publish it. Okay, so now we have to deal with Python publishers. Let's see. Python publishers. Python. Actually, I think this this example already had publishers in them, so might as well try to use it. So we got publisher, ROS publisher. Publish what? So we want to publish strings. String. That's fine. Where's the string being used? It's not being used at all. Okay, that's fine. So we'll just copy this. Let's define the publisher up here. Pub. Let's call it command publisher. We'll paste in our thing. The topic you want to publish to is to be determined. The type of message that we're publishing is a string. And I saw a string over here, so copy this right in. So you can see that there's different types of messages. We have the standard messages, sensor messages. Yeah, ROS has a lot of types of messages. If you're going to work more with ROS, you'll learn more about those. Okay, so string. So we want to publish strings, and the command we want to publish to is called. Okay, let's run our motor controller. So I'm gonna do ROS run computer. Okay, press tab to autocomplete. Oh, it's not working. Okay, we have to go back and source our file. So we're in catkin.ws. So I'm gonna do source devel setup.bash. Okay, and now we should be able to run our thing. So ROS run computer vision, press tab. Now it works. And the thing that we want to run is called motor controller. Okay, so run motor controller. Okay, so that's running. And we're going to open a new terminal. Okay, and what am I doing? Right, I want to look at the topic. So I'm going to do ROS topic list. So notice that now we can see what the topic name is, motor commands, because we just ran the motor controller. So it actually appears in our list. Another way is, I guess you could have just looked at the file itself and just see that the message that it subscribes to is called motor commands. So you can copy this from here, from this C++ file, and paste it right in. Okay, now to publish, I believe it's simply command pub.publish, and we just publish our command. I think that's how you do it. So command. Okay, so that should do it. Okay, let me try running this. So we have to navigate back into the folder, source, tutorials, source again, and then we're going to run our planner. Okay, so let's see what happens. I'll do RQT graph just to remind you what our graph looks like. We have the motor controller, publishes to Gazebo. We're about to start our planner, and that planner should talk to motor controller, and it should also subscribe to Gazebo for the images. So, okay, hide that for now. Actually, I'll just scale it for now. Yeah, let's run it. Let's see what happens. Python 3. Okay, let's go. So here we are. What is going on? Okay, so it's moving, it's going straight. That's good. It's really slow. It's only 0.2 times real-time factor. So it's going very slowly. Oh, okay, it was like frozen. But you can see it's actually moving. Wow, that's not that bad actually. See what happens. We're gonna, this is where we're gonna turn. So it's gonna be like, go right. Okay. Wow. I actually didn't expect it to be that good. This is like a lot better than I thought it would be. Wow, okay. This is totally unplanned. Like I didn't expect it to be that good. I wish there was a way for me to speed this up. But, wow, it looks, yeah, looks good. I'll probably like speed it up in post-processing. All right, we're about to hit the tricky turn. Let's see what it does. Let's see what it does. And oh, 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 oh no, it stops. Oh, wait, hold on. Oh no, it stops. Right. The default command is stop. So when it sees that both of the values are gray, it just doesn't do anything. Well, I think this is a really good point to just stop and let you figure out how to make the robot go around the obstacle course. yeah, I mean, I didn't expect it to be this good on the first try, but you know, there's still some improvements. It's like kind of slow, so maybe you could try making it go faster. That's a challenge for you to tackle. All right, one last thing before I end this video. I had this interesting idea, but it's not very like, it's not like you need it, but I thought it was cool, so I just wanted to show you. I was thinking, okay, so we have all this, we go through all this like if-else conditions, go left, go right. And I thought, why don't we display it on the OpenCV image as to like what commands we're taking. So I want to return the command. So we're publishing the command. So I'm just gonna delete that because it's kind of obvious that we're publishing here. So we're publishing the command, and then we're gonna return the command. So no plan. So inside here in the image callback, when we plan, we're gonna get the command back. So command is equal to plan. So plan is returning the command, right? And I want to draw shapes based on the type of command that we're receiving. So right now we're drawing a line, right? So let's draw something on top of the line. So if command is equal to left, let's draw something. I want to draw a circle. OpenCV2 draw a circle. OpenCV2. Circle, okay, should be simple enough. So we're going to do cv2 dot circle. Just going to draw it on the gray image. Gray image, I'm gonna draw. So if the command is left, I want to draw on our left circle, left point. So 300 by 700. So the coordinates, radius, let's say 5. I think that should be, yeah, that should be good. 5. Color, I want to be black. How about we make it white? Let's make it white, 255. And then thickness, 2. Why not? And we'll do the same thing for right. And we will do the same thing for straight, for go. So this is unnecessary, but I think it will look cool. So in this case, we want to draw at 500. This we will draw at somewhere in the middle, so 400. Okay, let's see what happens. Oh no, it stops. Okay. Let me give it a helpful push. So it actually sees the line. Okay, there we go. Hey, there we go. So now our image displays the command that it's running. Let's go right. Let's go straight. Now let's go right, let's go straight, go right, straight, right. Whoa. Isn't that cool? So this is about to hit the gray part, so it's going to turn left a little bit, or it's turn right, I mean. Now it's going to turn right. Oh, it's turning right, turning right, turning right, turning right, turning right, turning right, turning right. And then hits the yellow and goes straight. And turn left, go straight. Yeah, anyways, just last minute idea that came to my head. I think that's pretty cool, right? Okay, so that is all I want to show. And since we're nearing the end of the video, what should I do here? Right, last thing I want to show you is, before we end this, is the RQT graph. So I'm going to open up a new terminal. RQT graph. And let's see what it looks like when we're running all the nodes at the same time. Okay, yeah, you can see now, we got this triangle. Remember the slide that I showed you before? We have gazebo sending an image towards my planner node. This name comes from this, where we named our node this name, my planner node. And then the my planner node sends this string of commands into the motor controller. Motor controller sends stuff back to gazebo. So now you can see with RQT graph what the actual thing is, what is going on. Yeah, but that is all I want to show you. I really hope that you learned something new from this tutorial, learned something more practical than, you know, your courses or like whatever other sources may be. Yeah, let me know in the comments what you think of this. If you have any questions, because maybe I missed something. I probably missed something. I just kind of sat down, just went through this whole video in like one sitting. So there's bound to be something that I missed. But yeah, I really hope that you learned something new, and yeah, see you next time. Actually, one last thing. I think you'd be interested to know how to modify the racetrack yourself. So it's pretty simple. If you go into world, you can see that there's the course.png file. So literally, you just open it with your favorite paint tool. Mine is GIMP. And you literally just draw on it. You can take your paintbrush and you can just start drawing with whatever color you want. Let me so if I write something like this. And I hit save, Control S. Oh, no. I guess I had to export it. So export as course.png. You know, actually, I'll just make a new one, course2.png. So export it. Now, if we go into, so now we have two files here. If I go into course.world, where is it? Oh, sorry. No, it was in the other file. Course material. Here you can set the texture of your object. of the ground. So I'm going to select my second file, course 2. And then when we rerun our launch file, you get your updated course. So yeah, it's pretty simple. Feel free to make your own racetracks. But yeah, I think that's all.